out combining resources, okay? So this short lesson will get to that, okay? Okay, so with the least cost rule, which will very much sound familiar because it's very much like the utility theory that we did earlier in the year, okay? And if I can just remind you for a second, if you're a consumer and you're standing, with your cart at Target and you're about to put an apple into your cart, or maybe you're considering putting an orange into your cart, we know that from a utility perspective, as a consumer, you might like apples more than you like oranges, and if that's the case, then your marginal utility for the very next apple might be greater than the marginal utility for an orange, but we also assume that prices matter. And if oranges are a lot cheaper than apples are, it's very possible that the marginal utility per dollar of an orange might be greater than the marginal utility per dollar of an apple. And we're interested in you making your purchases, especially if you have a budget, so that you're always choosing first, the product that gives you the greatest marginal utility per dollar. In the case of a firm that's choosing resources, right, and more than one resource, we kind of do the exact same thinking, right? We are given a budget, okay? So this is a firm, let's call it Wallace & Company, that has $35 to buy two goods, right? Renting robots or hiring workers, okay? And there is some information that's going to help us understand what is it that we're really getting from the first, the second, the third, and the fourth robot, and the first, the second, the third, and the fourth worker, okay? We're very much interested in what's the marginal product, okay? How much can a rented robot actually make me in terms of the product? So let's say it's making hats. How many hats can they make? And what is the marginal product per dollar of the resource, right? So if I'm spending $10 to rent a machine, how much am I actually getting a marginal product for every $1 of rental, funds that I'm putting in there, okay? So if the first robot is giving me a marginal product of 30 hats, right, I know that I'm really getting three per dollar, right? I'm getting three hats per dollar. For the second robot, I'm really getting 2 hats per dollar. For the third robot, I'm getting 1 hat per dollar. And for the fourth robot, I'm getting, half of a hat for $1, okay? In the case of the worker is actually a little bit cheaper. It's $5 instead of $10. And of course, if the price of the robot were to change, right, it would go higher or it would go lower. That would affect the marginal product per dollar, okay? But in this case, we're interested in productivity. How many hats can a worker make me? Well, the first worker can make 20 hats, but because the price is only $5, that's really 4 hats for every single dollar. 3 hats for the second, right? 3 hats per dollar for the second worker, and 2 hats per dollar for the first, and let's say 1 hat per dollar for the fourth worker, okay? So if I were to go shopping, right, and actually purchase some of my resources, right, very, very first, I might actually, put money toward where do I get literally the most bang for the buck, right? Where am I going to get the most marginal product per dollar, okay? I will get that from the very first worker who will bring me 4 hats, okay? And I will pay $5. But because I have a budget of $35, I can continually shop around for resources, right? I might next buy the first rent the first robot, and that will cost me $10. I might then buy or hire the next worker, okay? So hiring 2 workers and renting 1 robot is going to cost me a total of $20 so far. I still have some money to spend, okay? And because I'm looking at the marginal product per dollar, I'm kind of indifferent, right? For the next purchase, I might again go with $5 for the next hiring the next worker, and then with a cost of $10, I might rent the next robot, okay? So when I rent the next robot and I hire the next worker, right? If I've hired the third worker and rented the second robot, each of those has exactly the same marginal product per dollar. Okay, that's something that we're looking for, that ratio to essentially be the same. And we're also spending all of our income. Okay, so in this case, I've reached a total of $35. Okay, and what combination of robots and workers am I going to maximize my output with? Okay, it would be 3 workers and 2 robots. Okay, and that would enable me to follow the least cost rule. Okay, and all I'm really doing in this case. Okay, so the important thing here is really this formula right here. This is the least cost rule. If I am looking to create a quantity of multiple resources and do this with being least cost, okay, I am trying to ensure that my marginal product, let's say for labor, over the price of labor, should be exactly the same when I've purchased whatever quantity of labor I'm purchasing, say 6 units or 6 workers. That should be exactly equal to the marginal product of capital over the price of capital. Okay, so for every single resource that you are purchasing, the combination of resources that you finally settle on, okay, should have exactly the same marginal product per dollar, okay? So the marginal product for labor over the price of labor should be the same as the marginal product for capital over the price of capital. And say, for example, you know, that these were both, 2, right? So maybe this was 10 over 5, marginal product of 10 over a price of $5 a worker, and maybe this was, 20 over 10, okay? In this case, we would say, all right, we are being least cost, okay? Because these fractions, are exactly the same. If it turned out to be that, say, this was 30 over 10, what we are looking to do is not make the fractions equivalent. We're not looking to have more labor so that we can make the fractions equivalent. We'd actually be saying the marginal product for capital would be 30, and the cost of capital might be $10 per unit, to rent. So it would be, we get greater marginal product per dollar for capital or for robots than we might for workers. So we're not being least cost. What we should do in order to ensure we have a quantity that's going to be least cost, we should purchase, more robots. We should rent more robots. And as you get more and more and more robots, this marginal product, because of the law of diminishing marginal returns, will start to decline, and ultimately, with greater and greater quantities of robots rented, we will have a final, robot rented where the marginal product for renting robots, right, over the price of robots will be exactly the same as the marginal product of labor over the price of labor. Okay, and so we're always looking to ensure that we have this formula. We have all of our resources kind of equivalent to each other. Okay, everyone, this is the last thing. This is the profit maximizing rule. Very, very different from the least cost rule. The least cost rule is basically saying if you're purchasing a variety of different types of resources, how can you ensure that you do that in a way that's going to be efficient in terms of least cost, okay? In this case, we're interested not only in being kind of productively efficient, we're really interested in allocative efficiency. How can we ensure that we're profit maximizing, okay? And maybe one way to look at this is graphically. Say this is a firm, okay, and the firm has a purchase for labor. The firm also has a purchase for capital, robots. Let's say that labor is $5, for each unit hired, and maybe $10 for every single part of capital that is rented, okay? Both of these also have an MRP curve. So this is the marginal resource cost, or the wage. In terms of capital, we tend to call this rent, but it's also the marginal resource cost, the cost for the firm for every single robot that is rented. And there's also a marginal revenue product. If we're trying to figure out if we're profit maximizing, we're only profit maximizing when the MRC equals the MRP for labor. So let's say this quantity here for labor, and also where the MRC is equal to the MRP for this quantity here for robots, okay? We are only profit maximizing if the number for the MRP, say in dollars, right, is $6. And here, you know, because we use 5, let's go with 5. Say this is labor, okay? And the marginal revenue product was $5. The additional, you know, worker is lending itself to $5 of additional revenue, and the cost of hiring another worker is $5. In this case, we know that this is profit maximizing, not because these two fractions are going to be exactly equal to the marginal revenue product of capital over the marginal revenue cost of capital, but because they are equal to 1, right? They're equal to each other, but notably they're equal to 1 because MRP has to equal MRC. The same thing with robots. If we're profit maximizing, we're not only profit maximizing with labor, we're also profit maximizing with capital. Graphically, it would look something like this, but the profit maximizing rule would suggest maybe this is, you know, 10 over 10, MRP of 10, and a resource cost of $10 would mean that we have an equivalent MRP and MRC for robots, okay? And if we are profit maximizing, generally MRP equals MRC for every single resource we're purchasing, even if it's like 15 different resources, okay? And notably, this is very different than the least cost rule. We do note that if we are if we are profit maximizing, we also are least cost, okay? But they do mean different things. Profit maximizing refers to allocative efficiency, and the least cost rule really refers to more of a productive efficiency, okay, that the firm is guaranteed to be doing that at least cost, okay? There is a worksheet on materials for class that's called Practice Worksheet for combining resources. Do that worksheet first. There's also a problem set that you are going to be asked to submit of a few free response questions that put some of these ideas to work. The free response questions, again, will be submitted, but you need to practice first the combining resources formulas, just get your feet wet in them, and then go to the free response questions, okay? And those are 2 things you can work on in class today.